we're now going to look at how to find outliers for box plots or a box and whisker plot. Finding the outlier, there is a specific formula. We're going to look at lower outliers and we're going to look at upper outliers. If we're trying to find a lower outlier, it would be a point that is less than the difference of Q1 times 1.5 and the IQR. In order to find the upper outlier, instead of Q1, we now have Q3. Instead of subtracting, we now have adding the 1.5 and the IQR. Now, the IQR stands for interquartile range. And the interquartile range is our Q3 value minus our Q1 value. And that's how we're going to find our IQR. So we're going to be drawing a box plot and we're going to determine if there's any outliers. First thing that we need to do when we draw a box plot is put the numbers in order. So our first number is 3, then we have 4, 5, 6, 8, 8, 9, 11, 12, 16, and 24. Once we have the numbers in order, we're going to count how many numbers there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that means that there's 5 on the left-hand side. There are 5 on the right. So that means our median is 8. And what we're going to do next is we're going to find our Q1 and Q3. Q1 is the middle of the first half of the data, which is 5. And Q3 is the middle of the second half of the data, which is 12. And of course, the minimum and the maximum are the easiest because that's the lowest and the highest in our set of data. So before we actually make the box plot, what we're going to do is we're going to check to see if there's any outliers. How we check to see if there's any outliers would be using the formula. We're going to first find our IQR, and that would be 12 minus 5. Remember, it's our Q3 value minus our Q1 value. So that's 7. Now, in order to find our lower outlier, what we're going to do is we're going to take our 5, which is our Q1. We're going to subtract 1.5, and we're going to times it by 7. Now, in order to find our upper outlier, we're going to take our Q3 value, and our Q3 value is 12. We're going to add 1.5, and our IQR is 7. So you may want a calculator. A lower outlier is going to be anything less than this number. An upper outlier is going to be anything greater than this number. So we're going to take out our calculator and we're going to calculate it. 1.5 times 7 is going to be 10.5. 5 minus 10.5 is negative 5.5. So we're going to see, is there anything lower than negative 5.5? And the answer is no. The lowest number is 3. Now looking at our upper outlier, we're going to take the 1.5 times it by 7, and we get 10.5. We're going to add it to 12, and that gives us 22.5. Is there anything higher than 22.5? And the answer is yes. If you look at our data, this right here would be 22.5, so then that means that we have an outlier at 24. So now what we're going to do is we're going to graph this. I'm going to start at 0, and I'm going to go all the way to 24 by 5s. Now, I'm going to put a dot at 3. That's our minimum value. I'm going to put an X at 24. The reason that I'm putting an X is because that's an outlier. Now what I need is a new dot. I'm not going to use my boundary point. This is just an imaginary boundary point. Anything past that is considered an outlier. What I'm going to do is use my next highest point, which is 16. So I'm going to put a dot at 16. Then I'm going to put lines at 5 for my Q1, 8 at my median, and 12 at my Q3. And that right there is my box plot or my box and whisker. Let's look at the second example. If we're looking at this one right here, what we're going to do is we're going to put the numbers in order. So we have the least value, 45. Next one is 55. Then we have 58. We have 59. We have 60 and 60 again, and 63 and 68 and 68 again, 70, 72, and 79. We're going to count how many numbers there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's an even number. So that means I have 6 on the left, I have 6 on the right, and the median is going to be right in the middle. So I have my minimum, which is 45. I have my median in between 60 and 63 is 61.5. Q3, and my maximum. Now, if you're not sure how I figured out the 61.5, what you could do is you could take the two numbers that are around the middle, 60 and 63, and you could divide it by 2. And that's one way of finding 61 if you can't figure out what's in between the two numbers. Now we're going to look at these 6 numbers, and we're going to look for the middle. So in between 58 and 59 is 58.5. And between 68 and 70 is 69. And of course, the maximum is 70. Before we graph it, we're going to determine if there's any outliers. So we're going to take our IQR, and our IQR is our Q3, which is 69, minus our Q1, which is 58.5. And when we subtract them, we get 10.5. We're first going to find our lower outlier. And in order to find our lower outlier, what we're going to do is we're going to take the 58.5. We're going to subtract the 1.5 times the IQR. In order to find the upper outlier, what we're going to do is we're going to take our Q3 value, which is 69. We're going to add 1.5, and we're going to times it by the IQR, which is 10. Now we're going to take out our calculator and we're going to figure out what this is. So if we take the 1.5 and we times it by the 10.5, that gives us 15.75. And when we subtract it, it gives us 42.75. We're going to look, is there anything lower than 42.75? And the answer is no. We're going to check the upper outlier. Remember, this is a boundary point telling us what would outliers be. So this is the upper outlier, would be the 69 plus 1.5 times 10.5 is the 15.75. Our upper outlier, when we add it, is 84.75. If we're looking at our maximum, nothing is beyond 84.75. So that means no outliers. So we're going to graph it just like what we did yesterday. We're going to draw our number line. We're going to start with our least value, 45. We're We're going to go by fives. 5, 60, 65, 70, 75, and 80. We're going to put a dot at 45. We're putting a dot at 79, which is right before 80. We're going to draw 3 lines, one at 58.5, one at 61.5, and one at 69. We're going to make our box. We're going to draw our whiskers, and that right there is our box plot, or our box and whisker.